Hello everyone, and welcome to lesson 3.2, which is on combining like terms. Before we begin looking at examples, let's take a quick look at what like terms actually are. A like term is a term with the same combination of variables and exponents. That means when I'm looking at 2 or 3 separate terms, in order to add them or subtract them, I have to see exactly the same thing as far as the variables and the exponents go. If there is one slight difference, you cannot add or subtract those things together. So again, I think that it's important to realize that we are only talking about, and I'm going to highlight it here, addition and subtraction when I talk about combining like terms. Multiplication and division we'll cover later. But right now, anytime we're trying to combine like terms, you need to look at the variables and the exponents. If they are exactly the same in 2 or 3 or more separate terms, then you can add or subtract those things together. If they are different in even one little tiny way, you cannot put them together. So, to solve, the best thing to do is group your like terms, then do your normal math on the coefficients. That means normal addition and subtraction on the coefficients, and then we rewrite the variable and exponent combination at the end. So that's a big thing. I'm highlighting the third step too. Whenever we are combining like terms, we don't need to make the problem harder than it is, right? We are literally doing math on the coefficients. That means the numbers that are out in front. And the variables are just along for the ride. All we have to do is rewrite them. That's the purpose of combining like terms, is instead of saying things in 3 separate parts, we can just say it one time and it's simplified and we're ready to move on. All right, so let's scroll up here and take a look at 3 examples of combining like terms. Our first problem, we have 36x minus 5y plus 2x plus y. So, I can kind of spot my like terms. I can see that I have an x, and then separately I have y's and y's. So, I can group one set of like terms here, 36x plus 2x. And then separately, I have minus 5y, and it is minus 5y because of the minus sign that's in front of the 5 in the original problem, and then plus y. And we know that plus y is really plus 1y. We don't have to write that 1, but sometimes it helps. Okay, so going back to the x's, all we have to do is simplify that. 36 plus 2 is 38. The variable just comes along for the ride. Moving on to the y's, negative 5 plus 1 is a negative 4, so we write minus 4. And again, the y comes along for the ride. So now we have our final expression that's simplified. Remember, from 3.1, it's an expression because there's no equal sign. Our final expression is 38x minus 4y. Okay, so now moving on to number 2, we have the problem 7a plus a negative 3a plus 4. If we look at our variables here, we only have a's and a's, so that's great. All we have to do now is just group everything together. So we have 7a plus negative 3a. We can write that down as 7a minus 3a if we want, just to make things a little simpler. We know 7a minus 3a is 4a. Notice separately that we just have this number 4, right? Remember how we explained at the beginning that a like term has to have the exact same combinations of variables and exponents. There's no variable, there's no exponent behind 4. Numbers are their own group of like terms. And so since that's the case, that 4 just comes down on its own at the end because we can't do anything to it, and then we're done. So we were able to group 7a plus negative 3a to get 4a, and then the 4, because it's its own kind of like term, is off by itself. Okay, and then now we're on to example 3. Example 3 is 24x squared minus 3x plus 10 minus 4x squared minus 5 minus x. So this problem is much longer, and when you really get into doing combining like terms problems, you'll start to see these long strings of different terms that they expect you to put together. So there are a couple things that we can do to help us with that. So the first thing is just let's figure out what our like terms are. So first we see an x squared at the beginning, and then there's another x squared almost at the end of the problem. The next kind of like term we see an x, and then there's an x all the way at the end. And then our third type, which we just explained, are our numbers, which are 10 and negative 5. So now it just really comes down to grouping problems. To group the first two, we'll have 24x squared, and then we'll have minus 4x squared. And remember again, it's minus 4x squared because there is a minus in front of the 4 in the original problem. A good tip whenever you're trying to combine like terms is just, if you rewrite something and regroup it, you can just mark it out so that way you don't get confused. I've highlighted things here, so that makes it easy too, but sometimes I know not everyone has a highlighter ready to go. The next kind of problem, or the next variable that we have, are our x's. So that's a minus 3x, again because of the minus in front of the 3 in the original problem. And the minus x because of the minus in front of the x at the end. And then our last kind of problem that we use and that we have are just our numbers, which is 10, and then a minus 5 because of the minus in front of the 5 in the original problem. Now, to solve, again, we're not doing anything fancy. We're doing the exact same kind of math that we've done before. We look at our x squareds. We have 24x squared minus 4x squared. We do our subtraction on the coefficients. So 24 minus 4 is just 20. The variable and exponent combination is just along for the ride. Then we move on to the next one, which is negative 3x minus x. Remember that we could put a 1 in there if we really wanted to. So negative 3 minus 1 is negative 4. And the variable is along for the ride. And then our last one is 10 minus 5, which we know is just positive 5. Once we solve all those and simplify, we have combined like terms. And we have our final simplified answer of 20x squared minus 4x plus 5. So again, all we have to do is find our variable and exponent combinations, group them together, do the math on the coefficients, and let the variable exponent combo just come along for the ride. Hopefully this has helped you out. If you have any questions, as always, please let me know.